Okay, so nuclear power stations. We don't have a huge amount here in the UK. I think there's one in Scotland, one in Wales, and I think there's 3 in England, but you can go and find that out. So there are lots of benefits to nuclear power station, but they have one really big drawback, and that is radioactive waste. Okay, probably seen the symbol, haven't you? This one here. Okay. Okay, the waste that they do produce from the nuclear reactor is radioactive, and it emits all 3 forms of radioactivity, including gamma, so it's very dangerous. And the second problem with radioactive waste, if radioactivity itself wasn't bad enough, is that this radioactive waste can last for thousands of years. So it is not just radioactive for a week, a year, it is radioactive and dangerous for thousands of years. So any waste we produce from nuclear power stations now, we have to think that in 1,000 years' time, that many generations' time, people need to know where it is and how dangerous it is. So that is the major drawback. It's a pretty big one, isn't it, people? But on the flip side, there are lots of really good things about nuclear power. So let's have a quick look at nuclear power. So first of all, they use nuclear, a radioactive isotope. The main radioactive isotope they use is uranium, and they have uranium in rods in the nuclear reactor, okay, and these are called the fuel rods, okay. These fuel rods emit huge amounts of thermal energy as they decay. So just like when we burn coal in a combustion reaction, that also releases huge amounts of heat energy. There's no burning here, there's no combustion. These radioactive isotopes break down, it's called a decay, radioactive decay, and as they decay, they release heat energy, lots and lots of it. So a gram of uranium will release the same amount of energy as burning tons of coal. So we'd have to burn huge amounts of coal to get the same amount of energy as we would from small amounts of uranium. So because there's no combustion, there's no burning, there's no hydrocarbon, there's no fuel being burnt, this form of generating electricity does not produce carbon dioxide. So it doesn't have an impact on the carbon cycle. It does not produce sulfur dioxide or nitrogen dioxide. So it does not produce acid rain. It does not produce particulates. So it can't affect the lungs and the growth and the development of young children and the lungs of people with respiratory diseases such as asthma. This is a clean source of energy in that it doesn't produce any pollutants. The only thing that it does produce is, as I said, the radioactive waste. So we have the uranium rods. But as we said, these rods will get very, very hot. So we have to control that, because if they get too hot, something like Chernobyl. Now, I don't know if you've heard of Chernobyl. Chernobyl is a nuclear power station that exploded during my lifetime. I think it was in the 70s, but you'd have to look this up. And these fuel rods did not get controlled. The nuclear power station wasn't well maintained. It's in Ukraine. And it exploded. Some very, very brave men and women went in and contained it so it didn't get any worse. They lost their lives. They got massive doses of radiation, but they protected thousands, if not hundreds of thousands of people living in the local area. So Chernobyl is something you should look at and find out about. But the problem with Chernobyl is they did have control rods. So control rods are exactly what they say. They are rods that control the fuel rods. So we can lower those control rods. They can go, you can see, you can lower them so they completely surround the fuel rods, or you can lift them up so that more of the fuel rods are exposed. By doing this, when you lower them, they absorb the heat energy and they cool down the reactor. And when you lift them up, the reactor gets hotter. So it's just a way of controlling the heat being generated by the radioactive material. So all of these are contained in a reactor, I'm going to draw that in a second, but before I do that, I'm going to draw the steam generator. So nearby to the reactor, you have an entirely separate container of water, okay? And the heat energy released from the reactor, I'm now going to draw the nuclear, so the heat energy generated from the reactor, so I'm going to draw the reactor, okay, surrounding the control rods and the fuel rods, but the heat energy, okay, it does not come into contact with the water. All of the radioactivity is kept here in the reactor, okay? But the heat energy from this passes through pipes even that go through the steam generator. They don't come into contact with the water, but they act a bit like a radiator. They heat up that water, okay? And as they heat up that water, it generates steam, hence why it's called a steam generator. And that steam is then funneled out. Okay, so I'm now going to draw the containment unit, which will surround all of this, and it will contain all of the radioactivity. Okay, it's made from lead and concrete, thick concrete. Okay, and it prevents any radioactivity generated here from escaping. So the only thing that can get out of this containment area is the steam that is generated in here, and the steam that's generated in here that never comes into contact with the radioactivity material here. So let's just check. We've got the fuel rods made of uranium, which is a radioactive isotope. This emits huge amounts of heat energy as it decays. We have the control rods that can be pushed down to surround the fuel rods, or lifted up to expose more of the fuel rods. This allows us to, if we're controlling it, if the control rods are down, it cools down the reactor. If the control rods are lifted up, it allows more heat energy to be released by the reactor, and therefore you will produce more steam here. So the steam then comes out, and the steam is funneled to a generator. Okay, no, it's not. It doesn't go to a generator. It goes to a turbine first. And a turbine spins. That's what turbines do. So you know what wind turbine is, don't you? It's like a big, windmill. Okay. Steam turbines look a bit different. They're sort of cone-shaped, and when the steam pushes against them, it causes them to spin round. Okay. So here we have the turbine. The turbine then is connected to a generator. You don't need to know anything about these yet. You will learn about them in physics. But a generator is a coil of copper, which is why I've sort of coloured it this way, around a giant magnet. Okay, and when you spin magnets inside coils of copper, it generates electricity. Don't need to know about that yet. Just accept. So this is the generator. That's the turbine. This is the steam generator that gets heated by the heat energy released from the nuclear reactor. Inside the nuclear reactor, we have the fuel rods themselves, and the control rods that can be lifted up and down. That whole nuclear reactor is contained within a lead and concrete housing that prevents any radiation from getting out. Okay, the only thing that could get out is the steam, and the steam has come nowhere in contact with radioactivity. So we've generated the electricity here, and therefore that is connected to our pylons in the national grid. The national grid is how electricity is transported around the UK on pylons. I'm sure you've seen the pylons. You might have seen substations with big sort of yellow signs saying, danger of electrical, high voltage electricity. Okay, and then eventually it comes into your house and into your sockets. So let's go through it. No point in time have I talked about energy being made, created. Remember, energy is never created or destroyed. It's only ever transferred. So let's talk about transfers. We've got nuclear energy from the uranium. The nuclear energy is transferred to thermal energy or heat energy. Okay, that heat energy heats the water. The water starts to boil and move. So the transfer is from thermal to kinetic energy. That then steam here, it pushes the turbine and spins the turbine. So kinetic energy to kinetic energy. Then the turbine turns the magnet inside the coil, and that is a transfer from kinetic to electrical energy, and then that electrical energy, off it goes to the national grid. So that is a nuclear power station. Okay, there are variations in design, but this is the same basic principle. At the moment, we don't generate a lot of electricity via nuclear power in the UK because, as we've said, there aren't that many nuclear power stations in the UK. Most of our power stations are still coal-burning power stations. We still rely on that more heavily. We have we have big fields of solar panels. We have more and more wind turbines. We do generate electricity using tidal energy. We have some hydroelectric power stations which use gravitational potential energy, water high up, being allowed to sort of come down like a waterfall, and that kinetic energy spins a turbine. Okay, so we have lots of other ones, but we don't actually have many here because they produce radioactive waste. But balanced against that is the fact that even though this is a finite resource and will run out, uranium, we don't need a lot of it in comparison to the amount we have to burn coal in our power stations, but it will run out, but there's still plenty of this about. It doesn't produce any greenhouse gases, so no carbon dioxide. It doesn't produce any of the gases associated with acid rain, so no sulfur dioxide or nitrogen dioxide. It doesn't produce methane, which is another greenhouse gas. It does not produce particulates, which we've learned about last week. So lots of positives to this, but people are still opposed to them. So you need to develop your own opinion on how you feel about nuclear power. As I said, there have been accidents, Chernobyl being the big example, and Chernobyl was due to human error. It was due to not keeping this nuclear power station well maintained. Here in the UK, we're very good at monitoring our nuclear power stations, making sure all the parts are working. If they need replacing, they get replaced. We can shut down nuclear reactors and do maintenance work on them. The people who work in these power stations are very knowledgeable and they know their jobs very well. And the people who deal with the radioactive waste. We have somewhere in the UK called Sellafield, and countries all over the world send us on their nuclear waste to deal with, because Sellafield is the major nuclear waste processing centre of the world. Okay, and here they contain the nuclear waste in special barrels that are bright yellow and plastered all over with the nuclear symbol. They're buried in lead and concrete sort of containment areas, which are very well labelled and so on and so forth. So, we deal with radioactive waste very well here. So that is this on nuclear waste. There are some other questions that I haven't covered, like is nuclear energy linked to nuclear weapons, which you need to go and find out for yourself. I haven't told you what percentage of electricity nuclear power stations produce in the UK, so you need to find that yourself. And you need to find how many nuclear stations exist in the world. But I've sort of done most of the content that you can pick your answers from for these questions. So I'll say bye-bye for now. Bye-bye.